All right, good evening, everybody. So tonight's the night. Tonight's the night we finally get to power some loads with these inverters. So we're continuing our installation progress on the 10 kVA kit that I received from Current Connected. We've gone through and we've gotten the inverters mounted on the wall. We've gotten the new wireway up. We've gotten the bus bar system all set up. And so the DC side of things is all taken care of. So now all we need left to do is really finish up the AC side of things and then a handful of miscellaneous tweaks. I've gone through and done a lot of rewiring and reconfiguring off camera regarding just how my solar setup ties into my house as a whole, which really simplifies things and makes things a whole lot easier from the inverter side. So all we have really to do is connect just a couple of wires and we should be able to output power from the inverters and supply power to the house. So let's get that taken care of and utilize all this power that I've gotten stored that I haven't been able to use for a while. Let's work on the output wiring. We'll get our ground wire come down to our bus bar that's down here in the wireway, and we'll just start figuring out the different cable lengths and everything that we're going to need to get the output wired. So it's going to be a little bit of time for me just standing and thinking again. We've gotten to that point now where we got to figure out every little piece again. Because all this I had, once I figured out the layout, then it's do it and get it done. But now we're to the next stage, which is wiring everything, which just means I need to look and get everything run. All right, so one last thing before I move on to other things. I had thought these lights actually all stay lit green if it's working. So when the inverters were off, the lights weren't lit. So I tried turning the inverters on, and the lights still aren't lit. Then I looked in the manual, and what happens is these will stay off if everything is good. When you see a red light, that's when you know the fuse is blown. So it's just different from my initial expectations, which is fine because then that means at a glance, if you see red, you know something's bad and you don't have to utilize power for any always on lights for your fuses. So things DC wise are working well. I'm going to switch out these for PV lines because it looks better. But I completely forgot about the fact that I need to run a ground line down here somewhere, as well as a communication line. So I got to figure that out still. AC wise, I've got my main ground tied into the panel over here. I'm going to do a line splice up here. So I'll put a couple Polaris connectors up here and have, these are my grid input, or AC in. So I'll have the Polaris up here, one set coming to the top of the transfer switch. The other set will go down over as the AC in for both inverters. The center lugs will come over to the 60 amp breaker, and then the lower lugs will be a phase 1 and phase 2 for my inverters. So I'm hoping to make some decent progress. But overall, things are moving well. I think that I should have most things wrapped up by tomorrow or Friday. At least have the AC wiring done. I have the servo connections are going to be a whole nother thing to figure out where I want everything laid out. But I think I'll probably mount the servo display right here. So pretty Sweet looking install though. Have to admit I like the blue. All right, so it's been several days of me sitting and waiting and refreshing tracking numbers, waiting for parts to show up, and it was supposed to show up yesterday and didn't show up, and then I didn't think it was going to show up today, but it actually did. So I've been waiting for this Morris connector, a three-way Morris connector, so that I could get my final AC output neutral set up, so that my AC outputs can come down from my inverters, combine into one, and come up into here. So I already have the red and the black cables. Everything's already tied into here. I already have my L1 and L2, red and black, cut to length for both inverters. They're both measured to be exactly the same length, because you want to keep a balanced, I guess from my understanding, some kind of a balance between leg 1 and leg 2 for those 240s, so you don't have any voltage drop, maybe? And somebody will correct me, but you want to keep as close to the same length as possible, just like with your battery cables. You want to keep them as close to the same length. So, but I have not measured and cut the neutral yet. So let's get that all figured out lengthwise, and then we'll get it wired in, and then we will flip the switch. I have been waiting for days to flip this switch and see if it's going to work. So let's not waste any more time. It's almost as exciting as when these things show up in the mail. You know, you're waiting for that last part. I don't have AC in yet, because I'm still waiting for some more of these. But for AC out, at least I can use the AC out. And if I have to, I can flip that. Whoops. I can flip this back up and go back to grid power if I have to. But it's sunny out right now, so let's use that power. These batteries are all topped off 100%. They've been that way for like 2 days. They haven't been used. So just for good measure, I did turn off all 3 inverters. Well, I turned off the 2 inverters and the charge controller. And so you can see here on my display, off, AC loads, DC power, everything's off. So we'll run this is leg 1, leg 2. Remember, we made the discovery last time that they actually wrote L1 on the inside here, which was awesome to see. And then looking inside at your terminal blocks, on the left, you've got your AC out. On your middle is AC out 2. And in the right, it's AC in. So we're going to wire everything up to this far left block this time. So like I said, we've got our leg 1 already cut and measured. When you put them in these terminal blocks, you actually have to clear quite a bit of jacket off of the wire, because it's going to want to slide up in there quite a ways. So I'd almost say you almost want to clear almost an inch to come up in here. And then one other thing, depending on how you wire these things up, because I'm using the trough, this is a little bit different. But when you wire these up, I saw a video from Current Connected. If you're just using the liquid tight, you actually want to pull a handful, about 8 inches, to come up into this cavity. Actually, this whole thing's 8 inches. So you probably want to pull 10 to 12 inches. You want to pull it up in here, and then you want to bend it back and actually give yourself kind of a loop, kind of like this. And then put it up in here. And the reason being that if you ever have to move anything around, this way you would have some extra wire. If you only went straight up in, you have no playroom whatsoever. If you have to move things, make any changes, you're having to rerun new lines. Now for me, it's a little different. I actually am giving myself extra room down here in my wireway so that my wire can just come straight up into the inverter itself. But if you're just using liquid tight, make sure you pull extra and give yourself a good bend or a good loop so that you can have extra room just in case. I would imagine most people are probably setting this and forgetting it. And that's really good. You want to be able to set it and forget it. Me? Well, in 8 months, I've already swapped out inverters. Who knows what's next? If I have to add another set of these, I have to move everything around again. So try to plan ahead. And that was the whole suggestion from Current Connected on making that big loop. So your labels for what each terminal is printed right up above. So you can see neutral, PE is ground. I don't remember what the P stands for, but I'm assuming the E is earth. And then you've got your L for line. And then the same thing here. Neutral, PE, line, neutral, PE, line. So we're going to be putting the black one. Not there. Black one will go here for line. And then our neutral will go in on the left. Nice and snug. And then, like I said, these are beefy terminals. These can take up to 2 gauge wire, I believe. Make sure our ground is still snug. Line is nice and snug. And since we're here, and since we've already got the other L2 line done, we're going to go ahead and get that all tightened in as well on our L2 inverter. And again, you can see you've got quite a bit stripped back because it's going to end up going in about like that. And you want as much contact as possible without it coming out of the terminal. Power lines and cables all over the place. Nice and snug. And check our ground. So we've got our neutral coming down in here. And I want to make sure that I still have a little bit of extra playroom in case I need to make any adjustments up in the disconnect. You know, the problem with cleaning up your tools between jobs is you don't know where you put them. So we'll give a little snip right there. Boy, that's tight. Clean the ends off. And while I'm at it, I want to kind of clean up some of these lines in here. So if you've never seen one of these Morris connectors, Polaris connectors, they can they're used for combining wires together. So you can actually combine. This one's from 2-aught up to 6 gauge stranded. 2-aught stranded to 6 gauge stranded. 600 volts at 90 degrees Celsius. And so it's actually, you can come in either side. So you can bring your wire in this way and split to 2 here. You can come into any one of these. Now you can only have 1 wire in each row. So I'll end up bringing my main neutral. It'll come in through one of these, and then the other 2 will be the outs going up to the inverters. So just to make things easy, I'll put the line in on the bottom. And these have a I think it's like a dielectric grease already in there. Maybe you can see it, maybe you can't. Maybe it's a deoxidizing, I don't remember. But then you want to make sure you strip back enough wire that when you tighten this down, it's actually biting down on the wire and not the sheathing. So we will slide it in and just start slowly tightening it down. I hadn't actually paid much attention to these in the past until, oh shoot, it might have been watching a mixture of Gavin Stone's channel and Engineer 775 utilize these. And the other thing, you got to make sure you save these caps when you're done. because if you have to change things up, they're reusable. Tape them to them, put them near them, something. I'm just going to leave them in the back of this wire trough right now. To figure out the proper length for these, you want to go based off of the furthest inverter. So let's run our line to our furthest inverter and just get an idea of how long we need it to be. Something like that. Give ourselves a little extra. And these are so hard to cut. They're so thick. These cutters probably are not even made for this. So we've got our length of wire. I'm looking at my scrap pile here. We'll run these. Kind of want to keep the AC outwards in the trough because I'll know what they are in the boxes. So we'll just feed one up into inverter 1, feed one up into inverter 2. So you can see inverter 1, and over here inverter 2. And then down here, remember I said that you can only have one wire per row. It'd be awesome if I could just connect to the opposite side of my line in, but you can't do that. You're not supposed to. You probably could, but you're not supposed to, so don't do it. I guess my mind is just working input and then line 1 and line 2, so that's just how I'm going to do it. So we will pop the cap off, pop the top off. We need to loosen the nut. Actually, I guess it's a bolt, isn't it? And then because of all this, we want to give our wires some decent bends. I could be wrong because I'm no electrician, but I think aren't these used for like the main feeds that come into your house? Like from the pole, the wires come from the pole, they go to the top of the mast. And aren't these Polaris and Morris connectors what's used to connect the line from the pole to the lines on your house? I think they are. And then they just wrap them all in duct tape. That'd be funny. They wrap them all in electrical tape. So we will cap off that one. It's going to be hard to show you this, but the way I slide the wire into this, let me use this as an example. I kind of push it hard against the back and then slide the wire in so that the wire stops when the shield hits the metal lip in here. So that way I know that the shield is not getting pushed inside the hole. I hope that makes sense. Because if you just push it in, you could end up getting your shielding inside, and your nut and your bolt could be biting down on the shielding, which you don't want. You want it to have good hard contact with the wire, not the shield. So yeah, I'm waiting on a couple more of these for the AC input side. For the time being, our AC output is connected. All right, I'm gonna go upstairs and tell everybody the power is gonna go out for a minute. Ooh, I need to turn off my computer too. Thanks for reminding me. Because I have introduced this, it changes how the power is gonna flow in the house, because right now I'm using an interlock kit, which the interlock kit is taken off of my main breaker right now. So this panel can be powered while I am solely on grid power. But I need to throw the interlock back in so that we can't have multi-power flowing again. And then the way this should work, and we're going to test it. AC in is going to come in through here, And if I flip this breaker up, this will be AC in. If I flip it down, it'll be AC out. The generator interlock kit is going to prevent me from having grid power going to the panel at the exact same time as inverter power. And so this panel here will be supplying my main sub panel. My house is wired so wonky, it's not even funny. And it's not by me. I'm trying to fix it. But so this interlock will determine what power goes to here, and then this, right now this double 60 breaker up top here feeds that other sub panel, and it'll be controlled through the interlock kit. So we'll have to get all that reconnected and interlocked back in so that it's one kind of power or the other, of which I'm going to end up putting a big piece of tape over top of the main breaker so that we can't turn it off anyways. I'll probably end up disconnecting that from the mains and then removing the interlock kit altogether so it won't be connected at all. So then this will be the only way that power gets supplied to that. Now that I have this transfer switch, it's going to make things so much simpler, and it's going to help me simplify my electrical. So let me get that done, get the breaker turned back, get the interlock on, turn off the computer, tell everybody power's going out, blah, 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 and then we'll be back to turn everything on, to test it as we turn everything on. And then we flip. Where's it at? Flip the switch. So it kind of helps to hit the record button, which I didn't do. So that whole dialogue that I had is gone, but it's fine. I have the interlock kit back in. And for those of you that aren't familiar with what an interlock kit is, they're typically used for generators. They only allow one power source to be turned on at a time. So you see, it even has standby written here. But with this breaker turned on, I cannot turn on the main power. In order for this breaker to be turned on, this breaker has to be turned off, which then drops this tab, lets this tab drop, and then I can turn on the main power. But for our case, I don't want main power. I want my solar power. So now that our panel's back the way it needs to go, let's head into the utility room, do one final test, and then turn stuff on. All right, so we've got our breakers reset. The interlock kit is back in. We are going to power on just the inverters. We're going to leave the charge controller off right now. So I have a camera up on the servo display so we can see what happens there. We're going to turn on the inverters. We're going to test the voltage at the inverters. We're then going to test the voltage at this switch, input and output. And then we are going to have Ian throw the switch. I'm going to see what happens. Actually, Ian, there's two switches down here. I want you to click on the side closest to you on both of them at the same time.
3, 2, 1.
All right, we've got green lights inverting on. We can see on the screen it says that it's inverting. Ian, you're going to hold this. Make sure that it can be seen on the screen. And we're going to switch to DC. So we are going to test line 1's output hot to neutral. And tell me what you see. Wait a second. This is AC. We're actually back to AC now. Woohoo! All right, let's try it again. Hot to neutral.
119.5.
Okay, we're going to check leg 2. Hot to neutral.
119.3.
Okay, we're going to check hot to hot.
238.9.
Okay, good. Now we're going to come over here. We're going to open this up. So this is now hot. So we are going to test hot to hot.
238.8.
Hot left, leg 2 to neutral.
119.3.
Hot 1 to neutral.
119.5.
Okay. So right now, we don't have any, we're good. We're going to close this up. I'm going to open this box so that we can test over here as well, because I don't want to have any oopses. Oopses are bad.
Like when you had that giant explosion in the inverter. Well, not really giant, but you had an explosion near the inverter.
Well, when I had the portable one, the smoking coming out of the portable one, yeah, I don't want any of that to happen again. So you got to slow down. As excited as things are, you know, your adrenaline gets going. You're just dying to flip that switch. You want it to work. You gotta slow down and take your time. Right now, this panel should be completely dead. Should be. So we're gonna check it. So let's test here.
1.8. 1.8.
Is it volts, millivolts? What is it?
Volts. It's going down though.
All right. We're gonna check over here because this is our supply to the other panel. What are we reading?
0 millivolts.
0. Okay. So we have no power. We have no power in this panel right now. So Ian, what we're gonna do, we're gonna have you push up hard to make it lock into place. To go to grid power, and then we're gonna test it here. We will not turn on this breaker. Once we turn on this breaker, that will send power to everything else in here and to the other panel. We don't want to do that yet. So you're going to take this and you're going to push it up hard. Okay? So you just switched it to the grid power. Hold that. And we're now going to test this here.
240.5 volts.
Okay? Now, Ian, pull it back to the middle. Okay? And now go down to the bottom. Oh my goodness. I think I just lost a life. What you don't know is this panel slid down off the wall. It made a horrible noise right as Ian was pulling that breaker down. Oh my goodness. Why does this happen to me? Move this stupid thing out of the way. Don't touch it.
I'm gonna hold it.
I need to check my blood pressure. That freaked me out. All right, Ian. Oh, I did not do that on purpose either. We're gonna check here. What do we got?
238.6 volts.
Okay, if I go here.
And 119 volts.
And here.
119.5 volts.
All right. We are going to put the cover back on, and then we will turn that breaker, that stupid possessed cover, the moment we've all been waiting for. Our breaker is switched into inverter mode, or our disconnect is switched to inverter mode. As soon as we flip this breaker, we should be supplying power to that main panel and to everything in here. Coward, why are you standing back that far away? All right, ladies and gentlemen, in 3, 2, 1.
Hey, it didn't blow up.
I hear a little higher hum off of the inverters for a half a second. And that's it. So we're pulling 500 some watts right now off of the inverters. And let's turn on the charge controller again so that we can actually utilize the remaining solar power. But, ladies and gentlemen, we're running off of these inverters right now, which is awesome. So within the next day or so, I should be getting the other pieces for the AC in. So we'll get the AC in, hooked up and running. And for the time being, we're just gonna kind of run it through its regular paces. I hear the air conditioner kicked in. Remember, the air conditioner itself is not on these inverters yet. That will be a separate test. We'll do that all over again.
Hopefully this time it's...
But the blower is on these inverters. So I'm excited to see. I'm excited to see how it all works. Well, I can guarantee that this was not as exciting of a night for you as it was for me, because, I mean, aside from the fact that I probably should have changed my shorts earlier after the panel fell over and scared me. But I mean, just, it's awesome having the ability to utilize solar power stored in batteries and have that supply the loads to your house. I mean, I've had no solar power for the last 3 weeks, maybe? 3.5 weeks. I mean, it's just, you know, you tear everything down, and then it's a lot of trying to just figure out where stuff's gonna hang, where wires are gonna run, and oh shoot, I forgot, I need this piece, and then oh, I only ordered 1, but I needed 2. Just a lot of different things, but we're finally able to supply power to the house. And so the last big thing for this system is to get that AC in coming into the inverters. And that's gonna pose its own little challenges, because these inverters work a little bit differently by default than the 6500s that we used. So we'll get into that once we get the AC in all wired up, but I gotta wait for those last couple pieces. Remember how I said that you order 1 and then you realize later you need more than 1? Yeah, that's what happened with these Morris connectors. I ordered 1, thinking that's all I was gonna need, and lo and behold, I needed 3. So, it happens. Teaches you patience, right? But at least we've got power to the house. So with that, I'm gonna let y'all go. Y'all stay safe, stay cool, and we'll catch up with you later. All right, so I'm not good at waiting. I kind of wanted to know, how's this going to work with the biggest loads that I currently have hooked up? Am I going to completely lose power? What are the inverters going to do? I don't know. I'm going to have Ian upstairs. He's on the radio. He is going to end up turning on the water, the hot water, which is going to drain the water from the tank and the system, which will then kick on the water heater, not the hot water heater, the water heater. Yes, I know, I caught myself that time. And the well as well. So we're looking at 1,090 watts of draw right now. We're going to see a spike, a surge. Let's see what happens. Is it going to work? All right, turn on the hot water, please.
Okay.
And then stand in the hallway and tell me what the lights in the hallway do if they flicker.
Okay, the hot water is on.
1,092.
So far, it doesn't look like they're flickering.
Go ahead, turn on the cold water as well. We're going to force this thing to kick on. Nope, I hear a hum.
It flickered once.
So the hot water kicked in. We're at 5,300 watts. Ian said that it was a little quick flicker. Now we're just waiting on the well to kick in as well. But I'm still just hearing a faint hum coming from these inverters. I'm still waiting on the well. Unfortunately, with the air handler running, you can't hear the sound coming from these inverters. But again, it's just a quiet hum. We should be close to that well relay tripping though, that contactor closing. 5,400 watts. There we go. I just heard it click. $6,500 watts. I hear the fans kicking on the inverters. Sounds like the fan kicked on only on leg 2 because we're over some threshold. I don't know if 3,000 is the threshold or if 3,500 watts is the threshold, but the fan kicked on. All right, thank you. You can go ahead and turn that off. I don't want to push it anymore right now. I kind of want things to happen naturally, but I was very curious to see because, oh, and the fan on inverter 1 just ramped up. So it could be temperature, it could be wattage. We're still at 2,800 watts, so it could very well be a temperature setting. But right now, with it being Saturday night, we've got church tomorrow, so everybody's going to be making sure they're all cleaned up, taking showers tonight. So I wanted to make sure that we weren't going to have any, lights going out and things tripping and all that kind of fun stuff when somebody's trying to take a shower. But it works great, and it's quiet. I'm going to do a sound test on this, but it's so quiet. I mean, we are close to that 4,000 watts, and that's going to be the interesting thing, though. As far as the VA versus the watt rating, I don't know how much fudge room there is there. I mean, if you are using, because the water heater is a giant inductive load. So does that give us a little more flexibility away from that 4,000 and increase it so that we can use more because because half of the output power is inductive? I don't know. I mean, we had the well kick in, which is resistive. So I guess we just kind of have to try it and see how it goes. I could have really pushed it and had Ian turn on microwaves and all that kind of stuff, but I didn't want to. Not this time. We will at some point because we need to find out what the limit of this thing is. But I just kind of want to know naturally, how's it going to work? But so far, lights are still on. No problems.